Yes, and welcome to our Objective 4.7 notes. Objective 4.7 says, I can solve quadratic inequalities and graph my solution on a number line, and that, my friends, is what we're going to do today. So, let's start by looking at the graphs in these inequalities below. And the goal here is just to recognize what's occurring. Look at our function. We have x squared minus 8x plus 12, and that's graphed here. And they want to know where it's greater than 0, okay? So x squared minus 8x plus 12 creates this parabola. We were familiar with that. And if we wanted to find where it was greater than 0, we would want to find where it was above the x-axis. So that would be these portions here. Everything from here over and then all the way down to there and then working our way back up. Those would be our solutions. So our solutions here is an interval. All right, now if we look here, it looks like this is 2, this is 6. And when we solve these, we'll find the exact x-intercepts here. But with that information, we can say, okay, so all the x values from negative infinity to 2, not including 2 because that's where it touches. So we're basically saying all the x values from here over our graph will be above. And so we would use the union here, which stands technically for or. Everything from 6 to the right, everything from this x-intercept over would be above. So that would be our solution. Our solution are the x values from negative infinity to 2 or from 6 to infinity. So there's one example of what inequalities look like graphically. Here's another. 1/2 x squared plus 2x minus 6 is less than or equal to 0. All right, so think about this. Less than or equal to 0, that would be if it's on the x-axis or below. Right? Less than or equal to 0. 0 is the x-axis. So we would be looking at, we see these points here where it touches the x-axis. This looks like -6. This looks like 2. The x values where it's below would be this part of the graph. All right. Now those would be the x values. This time, since we want it to include on the x-axis, we'll use a hard bracket from -6 to 2. And that would be our interval of our x values that would create a true statement in this 1/2 x squared plus 2x minus 6 is less than or equal to 0 inequality. Okay, so that's graphically how to find our solutions. Let's talk about the steps to do it algebraically. So the first thing is we're going to rewrite the quadratic inequality as a quadratic equation equal to 0. We're going to not worry about the inequality to start. So we'll say x squared minus 10x plus, if I want this equal to 0, I need to subtract 10 from both sides, and then equals 0. Next, we'll find the critical values by finding the zeros of the function, aka the solutions. We're going to solve this. This one looks factorable. X minus 7, x minus 3 equals 0, which means that x equals 7, or x equals 3. These are our critical values. This is where our graph touches the x-axis. So what we're going to do is we're going to create a number line of these values. 3, 7. Okay? Now, what we're going to do is we're going to identify test points between each of the 3 sections. So my test points, I need one test point here for this interval, one test point here for this interval, one test point here for this interval. So I need a number less than 3. A good number to always use is 0. I need a number between 3 and 7. Good number to use would be 5. I need a number more than 7, we'll say 10. All right, now those test values can be any number so long as they're within those specified interval. So what we're going to do now is we're going to test the values from number 4 and identify where the inequality is true. So if I plug in 0 into my inequality, I will get 0 minus 0 plus 31 is greater than or equal to 10. All right, 0 minus 0, 31 is greater than or equal to 10, so that one works. Now let's try it with 5. So that'd be 25 minus 50 plus 31. Is that greater than or equal to 10? Well, 25 minus 50 is negative 25 plus 31. Is that greater than or equal to 10? That would be 6. Greater than or equal to 10? No. That one does not work. Now let's try 10. So when I do that, I would have 10 squared, that's 100, minus 10 times 10, which is also 100, plus 31 being greater than or equal to 0. So I would get, greater than or equal to 10. So I would get 31 is greater than or equal to 10. That is going to work. So we're going to graph our solution on the number line that we've drawn and write our answer in interval notation. Interval notation. That was our hard bracket, soft bracket stuff. So what we'll do here is we'll use, remember, an open circle means non-inclusive. Since we are less or greater than or equal to, we will have inclusive values here. Closed circle. And then we don't want the middle section, we want the sides going away from the center. So in interval notation, this would be, let's see here, negative infinity to 3 hard bracket union hard bracket 7 to infinity. There we go. All right, let's do a few more examples here. Make sure we understand what we're doing. Let's look at letter A to start. X squared plus 12x plus 32 is less than or equal to 0. So first step, change this to an equation equal to 0. Solve. So this we can factor x plus 8, x plus 4. So that means x equals negative 8 or x equals negative 4. So those are my critical values. Those are my CVs, critical values. So I'm going to place those on my number line. Negative 8 is less than negative 4, so it will be to the left. Now I need to find some test values. So 0 is a good one here. And we'll say negative 5 and negative 10. And now we're going to test our test values. So let's start with 0. If I do that, I would get 0 plus 32 being less than or equal to 0. Is 32 less than or equal to 0? No, it is not. Let's try negative 5. So negative 5 squared would be 25. 12 times negative 5 would be negative 60 plus 32. Is that less than or 0? 25 plus 32 is, what, 57? Yeah, so this will be negative 3 less than or equal to 0, which is true. So negative 5 works. And then we have negative 10. So negative 10 squared would be 100 minus 120, negative 10 times 12, and then plus 32. Is that less than or 0? Well, 132 minus 120. No, that's going to give me 12, and 12 is not less than or equal to 0. So my interval that works is the interval between negative 8 and negative 4. Since we are less than or equal to, we will use closed circles here and just connect our points there. And then in interval notation, that would be the interval from negative 8 to negative 4, obviously inclusive with our hard brackets here. All right, let's try one more together. Negative 2x squared plus 5x plus 10 is less than 3. So if I were to change this into an equation set equal to 0, it would be negative 2x squared plus 5x. Let's see, subtract 3 from both sides, so plus 7 equals 0. Oh boy. Now, if I want to solve this, a times c, negative 2 times 7 is negative 14. So we can factor this actually. So negative 2x squared. Factors of negative 14 that add to 5 would be positive 7x and negative 2. So factor these by grouping now. So I can take an x out here. I'd be left with negative 2x plus 7. I can take out a 1 here to leave me with negative 2x plus 7 equals 0. So I would have x plus 1 times negative 2x plus 7 as my factors.
Allison Crumbeagle, extension 7177.
Miss Crumbeagle's in trouble. Uh-oh. That's okay. So, solving my factors, I get x equals -1. I would get x equals 7/2. So -1 and 7/2 would be my critical values. So let's find some test points. 7/2 is 3.5, so we'll say 5. We'll say 0 between -1 and 7/2, and we'll say -2. And now we just need to test these values. So let's plug in -2. So -2 times -2 squared, which would become +4, plus 5 times -2, so that will become -10. And plus 10, is that less than 3? So -8, -10 plus 10 is 0. It's less than 3. -8 is less than 3 indeed. That works. Let's try 0 here. When I plug in 0, remember, my x's will become 0, so I'm left with just 10 is less than 3. That does not work. When I plug in 5, I'll get -2 times 5 squared, so -2 times 5 squared plus 25 plus 10. Is that going to be less than 3? Well, 5 squared is 25. -2 times 25 is -50 plus 35. Is that going to be less than 3? Yes, indeed. -15 is less than 3, so this one will work. Now, notice we're dealing with strictly less than, so we will use open circles. Draw them all over there to cover that interval. And in interval notation, this would be -infinity to -1 soft bracket union 7/2 to infinity. And there we go. That's how we can use algebra to solve quadratic inequalities. Hopefully we're feeling good. If we want to do some more examples, definitely check out those sample problems. Otherwise, if you want to get started on your own, get started with those practice problems. Be sure we're checking our answer, make sure we're getting everything right. This is Mr. Carter signing off. I'll see you next time.